Welcome to this presentation on a light-based interpretation of Euler's identity with implications on quantum computation. I'm Praveer Malik, and this presentation has been prepared for the IEEE 12th Annual Information Technology, Electronics, and Mobile Communication Conference. This presentation essentially is going to focus on what's been called the most beautiful equation in the world, which is Euler's identity. And the reason why it's termed the most beautiful equation is because it simply connects together 5 fundamental concepts of numbers in mathematics: 0, 1, I, the imaginary number I, E, and pi, in a simple equation. That's e to the power I pi plus 1 equal to 0. And I is an imaginary unit. E is a mathematical constant, which is known as Euler's constant, and it's pegged at value of 2.71828. And pi is also a mathematical constant, 3.14159, and is also the ratio of a circle's circumference to its diameter. The next 15 minutes, I'm essentially going to focus on the implications of considering Euler's identity to quantum computation. So I want to introduce very briefly a summary of a symmetrical multi-layered light-based model. I'm going to then speak about the significance of the imaginary unit I. Since E, pi exist between 2 and 4, the numbers 2 and 4, and Euler's identity has 1 and 0 in it, I'm going to, from a light model point of view, speak about 0, 1, 2, 3, and 4, the significance of these. And then I'm going to suggest that Euler's identity is a process of materialization, and finally end with some implications for quantum computation. The model of light is summarized in this matrix on the right-hand side, and there are 4 fundamental rows. There's, at the top, a layer of reality or a conceptual space that is imagined to exist when light travels infinitely fast. And if we briefly consider light traveling infinitely fast in some volume, and if we have light at its center, then we know if it travels infinitely fast, it's going to be present everywhere in that volume. And so the PR refers to this property of presence. We further know that if anything not of the nature of light were to arise, it will be overpowered by the nature of light. And so we have PO for power, which is a second property in that space. And if we consider that everything is connected in this fabric of light, then whatever appears or disappears is going to be recorded in the fabric of light, and therefore light has a knowledge of everything happening in the space. So we refer to that property as K. And then finally, since everything is connected in the fabric of light, there's a natural implicit harmony, and that's represented by H. So this is a conceptual space where we imagine light to travel infinitely fast, and it is typified by these 4 properties: presence, power, knowledge, harmony. Now, the second row over here signifies a quantization function where these ambiguous properties that we call presence, power, knowledge, harmony become more specific. So there's a differentiation or a quantization that occurs where presence becomes a set of presence, power becomes a set of power, knowledge becomes a set of knowledge, and harmony becomes a set of harmony. These are, practically speaking, 4 large sets with as many as infinite elements, with each set differentiating the property on which it is based. Now, in this model of light, there's another quantization that occurs that results in a 3rd layer. And in this quantization, there is yet another differentiation of the 2nd layer, in which, as we can see from this mathematical function here, every element that's created is a unique combination of the elements in the 4 sets that were defined at the previous layer of reality. And then finally, there's a 3rd quantization that essentially creates space-time energy gravity. And the way that this happens is because if we consider this layer of reality where R is to the base C to the base N, then we know we have infinite number of seeds, and these seeds require an arena in which to express themselves, and that's what we understand as space. These seeds will take a different amount of time to reach maturity to show the concept that's in them, and that's what time is. There's a energy that accompanies the materialization, and that's what the E refers to. And there will be a collectivity or a group of collectivities created such that seeds will have interrelation with seeds, or collectivities of seeds will have interrelation with other seeds, and that's what gravity refers to. So what we have here is a model of light in which essentially the speed of light is varied from the known speed of c at the bottom, where space-time energy gravity express themselves, to some hypothetical quantity that approaches infinity. And these are the four layers that can be thought of as four conceptual layers of light. And these will essentially create all the massive diversity that we experience around us. So now when we think about the significance of I, we know it's an imaginary number. It's a square root of -1. And it's an apparent paradox at the heart of mathematical reality, because given accepted rules of mathematics, square root of -1 is an impossibility. Yet, practically, we know that without I, many equations would never be solved, and many practical technologies would never have come into being. So I is a convenient precedent when considering the multi-layered light-based model that I just introduced on the previous slide. And more significantly, the existence of I in any mathematical rendering gives place or suggests something that clearly influences practical reality, though may not necessarily be considered as part of practical reality. Now, when we think about the significance of 0, 1, 2, 3, 4, and again, we have to think about the significance, because when we think of Euler's identity, then the constants in Euler's identity essentially fall between 0 and 4. So keeping this light-based model in mind, when we think about 0, we can think of 0 as being essentially related to this first layer where light is traveling infinitely fast. And this layer has infinite information and all possibility in it. So we can think of 0 as being that symbol of all possibility. Now, when we think of 1, it's a specific instance of what's happening or how this 1 is defined, or this 0 is defined. And essentially, it is bringing out in this model the notion of a unity. That is that the presence, power, knowledge, harmony exists in an implicit unity. And one thing to point out is that this state of unity, as expressed in this sub-equation here, is a subset of the state of all possibility. So we have here the significance of 0, we have a significance of 1. And 2, if we consider the next layer, R to the base C to the base K, where light is traveling at some hypothetical speed K, then essentially the meaning of 2 as derived from this mathematical model of light signifies a differentiation that's occurred, because from that essential field or space of unity, you now have differentiation that shows up as 4 large sets. So 2 signifies differentiation. And when we think about 3, we can consider these layers of light, R to the sub C to the sub N and R to the sub C to the sub U, which are realities created at different speeds of light. And here what we're saying is that what this model is essentially expressing is that whatever appears in space-time energy gravity, it first has to stabilize itself. So the seed that exists subtly in some conceptual space expresses itself as a first stability and is related to 3 because there are, in fact, 3 points at that one subtle unique point will differentiate into. And so there's the essence of what it stands for, which can be thought of knowledge in terms of the property of light. There's the static aspect of what it stands for, which can be thought of presence as a property of light. And then there's the power, which is the dynamic aspect of that unique seed. And that's why we have, in a sense, three vertices of a stable triangle. And so the significance of three becomes essentially stability. And then we have four, which is also a play on the same sets of rows in this matrix. But here, inside that space of stability, we can consider something called choice, and that choice manifests or materializes or matures into something we call harmony. And the moment that happens, then we have presence, power, knowledge, harmony expressing itself materially. And any expression of something that was implicit becoming explicit, we can think of as a manifestation. So it's a manifestation of the four properties of light more concretely. And so four can be given that significance of manifestation. Now, considering these meanings of 0, 1, 2, 3, and 4, we can now begin to give meanings to E and pi, which are key parts of Euler's identity. So E, we know, is, of course, associated with the exponential function, but the way we can understand it is that it essentially lies between the polarity created by 2, which is a device for experimentation, and 3, which yields a form of stability associated with 3. And so E lies between this experimentation and stability. And so it's suggesting some kind of exponential experimentation, but it's depicted as essentially a derivative. And we know that when we take the derivative of E to the power y, it has a property of yielding the very function that's being, in a sense, subject to the derivative. And so what it's implying is that no matter how close we get to 3, there can be an infinite amount of experimentation. And so E, essentially, when thought of as the derivative of E between 2 and 3, yields this concept of exponential experimentation. Similarly, when we think of pi lying between 3 and 4 signifies a constructive process in which the stability signified by 3 is subject to dynamism to bring forth a fuller manifestation 4. So we simply represent that as stability becoming manifestation. And the meaning of it is stability subject to dynamism. Now, essentially, we've derived or we've suggested meanings for 0, 1, 2, 3, 4, E, and pi. And that makes it possible to now look at Euler's identity. And we can see that when we think about these meanings of 0, 1, 2, 3, 4, E, and pi within a light model, then essentially it's expressing a process of materialization of information. And this process takes place through multiple acts of quantization. We saw 3 specific quantizations where 0 yields to 1, which yields to 2, which is the first quantization, which yields to 3, which is the second quantization, which yields to 4, which is the third quantization, by appropriately leveraging I, E, and pi respectively. And therefore, something that's immaterial becomes material, and therefore Euler's identity in this light-based model is a process of materialization. So if this is true, then let's think about implications on quantum computation. We have here what I would consider to be a variation of Euler's identity. And this is Euler's formula, which again has e to the raised to the power ix. So this is the general formulation. Of course, here we're taking x to be pi. And then as we increase the multiples of pi, we essentially get this function that's specified by cosine x plus I sine x, which is an undulating endless wave bound between some values on the vertical axis, but proceeding to infinity on the horizontal axis. Now, a simple way to think about this is that Euler's formula becomes a convenient, simplified probabilistic means to depict everything that goes on behind the quantum veil. And why is this the case? This is the case because no matter how much I becomes a multiple of itself, values will always fall between a fixed upper and lower bound. And here, if we specify them to be between -1 and 1 or between 0 and 1, then essentially it becomes a probability function. And in quantum physics, everything is considered to be probabilistic. And so we have an interpretation of quantum mechanics in which Euler's formula becomes the perfect means to express any probability that could potentially exist. So this kind of a quantum mechanical interpretation, of which the Copenhagen interpretation is the most accepted, basically places Euler's formula as a simplified probabilistic mean to depict anything that's going to go on behind the quantum veil. Now, by contrast, in this approach to the light-based interpretation of Euler's identity in this paper and presentation, the undulating wave is not a probability function, but rather can be thought of as constantly connecting possibility in conceptual spaces. That's the 3 layers of light above the layer of light where light's traveling at 186,000 miles per second, to the material counterpart where light travels at c. So essentially nothing happens in the material layer where light travels at c without some arbitration between layers of conceptual space, and that arbitration is suggested by the action of the undulating wave or by Euler's formula. So simply stated, this constant arbitration is nothing other than a process of computation which involves 0, 1, 2, 3, 4, and essentially makes material what's hidden behind the quantum veil. So this suggests an alternative way to view quantum computation as something creative, in which something that exists in some other conceptual space becomes material. So to summarize, in this point of view, quantum computation can become, or then becomes, a profoundly creative process arbitrating meta-level concept into material reality, and suggests that the field of quantum computation should be fundamentally rethought of. Thank you.